Autoflight pitch modes control climbs, en route cruise, descents, and supply vertical guidance and commands for approaches and automatic landings. The Autoflight system pitch modes are shown here. Toga, GS, and flare are discussed in a different lesson. You select pitch modes with these switches on the MCP. You control the pitch modes with the MCP and with the CDU. When FCCA is the master FCC, the Autoflight system uses data from the captain's barometric altimeter. When FCCB is the master, the first officer's altimeter is used. The flight mode annunciation shows autothrottle status and pitch mode. Autoflight pitch modes automatically engage an autothrottle mode if the autothrottle is armed. The N1 autothrottle mode tells the autothrottle to set thrust at the active N1 limit and keep it there. Speed is controlled by changes in the airplane's pitch. The FMC normally supplies the autothrottle with the N1 limit. Here, auto is active and the FMC automatically sets the N1 limit for the related phase of flight. When MCP speed shows in the autothrottle status field, the autothrottle controls the thrust to hold the speed set in the IAS Mach display window. When MCP speed shows in the pitch mode field, the autopilot controls pitch to maintain the set speed. Retard shows when the autothrottle reduces thrust to idle. When the thrust is at idle, the retard annunciation is replaced with arm. Arm tells you the autothrottle is armed, but it does not control thrust. When arm is shown, you can move the thrust levers as if the autothrottle was disengaged. If you manually move the thrust levers when the autothrottle mode is N1 or retard, the autothrottle returns to the target thrust when you release the levers. You can find yourself in a fight with the autothrottle. Above flight level 260, the IAS Mach display automatically changes to a Mach number in the window. Below flight level 260, the speed is usually in knots. Push the changeover switch to change the IAS Mach display window from Mach to knots. The MCP speed is now in knots. The Autoflight system pitch modes level off the airplane at the altitude set on the MCP. When VNAV is the pitch mode, the airplane usually levels off at the FMC altitude. But if the MCP altitude is between the airplane and the FMC altitude, the airplane stops at the MCP altitude. The Autoflight system also alerts pilots to level-offs and altitude deviations. In this example, the airplane is in a descent to a new MCP altitude. When the airplane is near the MCP altitude, you hear the altitude alert tone, see a box around the current altitude, and see an altitude alert box above each altimeter. When the airplane is near the MCP altitude, the altitude alert boxes extinguish. As the airplane levels off, the FMA changes to altitude hold. The altitude alert operates the same in climb. In level flight at the MCP altitude, if you climb or descend too much, you will hear the altitude alert tone. The current altitude box changes color to amber and starts to flash. The current altitude box flashes until the altitude error is corrected. Or until the error is more than the alert limit. Or until a new altitude is set in the MCP altitude display. If an autopilot is engaged in command, but no pitch mode is engaged, the autopilot uses the default mode CWS pitch. To change the default condition, you must select a pitch mode. Push altitude hold to engage a pitch mode. The default pitch mode is replaced by altitude hold. You use the level change mode to climb or descend to the altitude set in the altitude display window. In a level change climb, the autothrottle uses the maximum thrust. Thrust is set to the active N1 limit, and N1 shows in the autothrottle field of the FMA. In a level change descent, the autothrottle uses the minimum thrust. Because it uses the active N1 limit thrust or idle thrust, level change is best used for large altitude changes. In this example, ATC clears you to climb to flight level 350. First, set the new target altitude. Push the level change switch to engage level change. The airplane climbs to the new MCP altitude. The autothrottle status field of the FMA shows N1, and the pitch mode field shows MCP speed. When the airplane reaches flight level 350, it automatically levels off. The altitude acquire and altitude hold modes are discussed later. The vertical speed mode also changes the airplane's altitude to the altitude set in the MCP altitude window. With the vertical speed mode, you set the rate of vertical change with the vertical speed thumb wheel and display. The vertical speed mode usually causes small changes to thrust and the airplane's pitch attitude. Because of these small changes, the vertical speed mode is best used for small altitude changes. You can engage vertical speed in two ways. If the airplane is in altitude hold, set the MCP altitude display window to a new altitude. Set a new MCP altitude of 8,000 feet. VS in small white letters tells you that the vertical speed mode is armed. To engage the mode, you select a target vertical speed with the vertical speed thumb wheel. Set a vertical speed of minus 500 feet per minute. The large green letters on the FMA show that vertical speed is engaged. The short magenta lines on the vertical speed indicator show the selected vertical speed. The vertical speed mode automatically engages MCP speed for the autothrottle. In this example, MCP speed was engaged while the Autoflight system was in altitude hold, so there was no change in the autothrottle mode. You can use the vertical speed thumb wheel to set the vertical speed for a climb or descent. Move the thumb wheel down to set a positive vertical speed and climb. An arrow and label show the correct direction to move the thumb wheel. To descend, move the thumb wheel up to set a negative vertical speed. If you want to descend but accidentally set a positive vertical speed, the airplane climbs. Because the airplane moves away from the MCP altitude, there is no automatic level off. If you are already in a climb or descent, you can push the vertical speed switch to engage vertical speed. The airplane's vertical speed shows on the MCP. The pitch field of the FMA shows vertical speed engaged. To change the vertical speed, move the thumb wheel. Set a vertical speed of plus 500 feet per minute. The climb continues at 500 feet per minute. The Autoflight system uses altitude acquire and altitude hold to automatically level off the airplane. The airplane starts to level off before the MCP altitude. Altitude acquire replaces vertical speed as the pitch mode annunciation. The point at which altitude acquire engages is calculated from the climb rate of the airplane. When the level off is complete, altitude hold replaces altitude acquire. When altitude acquire or altitude hold engage as pitch modes and the autothrottle is armed, the autothrottle engages in MCP speed. Automatic level-offs after descent are the same. You can also use the altitude hold switch to stop a climb or descent. If you engage altitude hold when the airplane is at an altitude other than the MCP altitude, the airplane levels off at the altitude where the altitude hold switch was pushed. The level off does not occur immediately. The airplane momentarily descends below the altitude in a level off from a descent. And momentarily climbs above the altitude in a level off from a climb. In this example, the airplane is in a descent to 16,000 feet. Use the altitude hold switch to stop the descent. The altitude hold switch was pushed at 17,400 feet. The airplane descends below 17,400 feet during the level off, but comes back to the altitude where altitude hold was pushed. Altitude hold replaces the VNAV path annunciation in the pitch field of the FMA. The autothrottle status field is now MCP speed. After altitude hold engages, the AFDS holds the uncorrected barometric altitude the airplane was at when the mode engaged. Later changes in altimeter barometric setting do not make the airplane climb or descend to follow the new indicated altitudes.